range for domain, it's all possible x values.
Could you please present your screen?
Yep, I'll present it. Thank you.
Very well.
That's the other thing. If you hop into the breakout rooms and come back, you have to re-present every time, and sometimes I forget. Alright, so all possible x values for the domain. So when it means possible x values, that means x values that don't do anything illegal. And there are two things in math that are illegal. So two things that are, we'll call it illegal. You get put in math jail if you do this. So rule number one. You've been told since you were really, well, since elementary school probably, you can't divide by what? What can't you divide by? 0. Very good. So if you end up having an x value that ends up dividing by 0, that's not allowed. So you can't divide by 0. And the second thing, you can't take the square root of what?
One, correct?
Well, you can take the square root of 1, but if it was negative 1, you couldn't. So what's the difference? You can't take the square root of a negative number. Okay, can't take the square root of negative number. Those are two rules that if you follow, you can figure out the domain. Okay, so here's an example. An example to find the domain. If it's y equals x squared. Well, you can't divide by 0 and you can't take the square root of a negative number. There's no fraction here, so there's no way we're going to divide by 0. And there's no square root here, so there's no way we're going to take the square root of a negative. So there's no way we could do anything wrong. We can't do either of the two illegal things, so the domain would be all real numbers. And it says real because that's the type of numbers we're working with. That's the type of numbers that you're familiar with. All integers, all fractions, all decimals, all square root of 5s, which is irrational, those are all real numbers. Okay? You could never divide by 0 or take the square root of a negative number there, so it's all real numbers. If we looked at the graph of y equals x squared, which we've done several times today, if I followed along on my parabola, this is going to go forever to the right. I mean, it's going to go up a lot, but it's going to go forever to the right, and it's going to go forever to the left. Okay, there's no holes in the graph. A hole in the graph would show that there's some x values that don't work. This is a continuous graph that goes forever to the left and forever to the right, so it's all real numbers. Now, I'm kind of lazy. I don't like writing out all real numbers every time. I like to use fancy symbols. So this is all real numbers, and it looks cool too. It looks like it belongs on a baseball hat. So if you want to write that every time, that means all real numbers. Okay? For domain, y equals 4 over x. This is another example. Okay, you can't divide by 0. In the bottom of this fraction here. Yeah, if x is 0, it doesn't work, right? We can't divide by 0. So this would be all real numbers for the domain, except it can't be 0, because that would give you 0 on the bottom. So the domain of this is everything except 0. Another example, I'll kind of do the same type of problem if it was 5 over x plus 2. That's going to work for all everything. Make the bottom 0 here. There's only one number that's going to make that 0. What is it? Good, -2. If x is -2, that's going to give me 0 on the bottom, and that's not allowed. Okay, so it's every number except for -2. What about y equals absolute value of x minus 3? Okay, so absolute value function. What about divide by 0 here? No, there's no fraction. Are we ever going to take the square root of a negative? No, there's no square root. So the domain of this is all real numbers. Now, we are only really concentrating on two types of functions in 1.1. And probably most of this chapter we're only dealing with parabolas and absolute value. If I ask you, what is the domain, and it's a parabola, or what is the domain, and it's an absolute value, this is your answer every single time. All real numbers. Because parabolas and absolute values work for every single number. Okay, it's always going to be all real numbers. Absolute value of x minus 3, we now know that the vertex is 3, 0. And it's just like a parabola, but it's a V. Looks like this. This goes forever to the left and forever to the right, and there's no holes in the graph. Okay, so it's all real numbers. So that is domain. Okay. If we want to talk about range, the range of a function is all possible y values. Okay, so what y values work? Range is a little bit more difficult. For our purposes, we're probably going to either rely on our calculators a little bit, or if you can find the vertex, you're in really good shape. So possible y values. So if I look at y equals x squared again, our parent graph. Will this parabola ever come down here? It never will. The parabola, its lowest point is on the x-axis. Okay? So remember, the range is possible y values. So the lowest y value is 0. Could that parabola ever go through -1? Is it going to go through -1? Is it going to cross this line, y equals -1? No. It bottoms out at 0 and then goes up again. Okay? So the lowest y value is 0. So we would say it's all y greater than or equal to 0. That's your range. Range is y value, so your answer is going to be y something. In domain, we talked about the x because it's the x values. You can't be x is negative, can't be -2. It's x for domain, y is for range. Okay, if I looked at this parabola, x plus 2 squared minus 3. Well, if I was going to make a sketch of it, I could find the vertex. Can anybody tell me what the vertex is of this parabola? I'd be impressed if anybody could do that. That's all right. So, what'd you say?
4 -3.
Close. He said 4 -3. It's not 4. What does the plus 2 do? It's a Melody says 2 -3. She's even closer. But the plus 2 is going to move it left 2. It's the opposite of that. So it's actually -2 negative 3, because it goes left 2, down 3. So whatever's in parentheses, it's the opposite of that, comma, that, and that's your vertex. And if you can find the vertex, the domain is not much more difficult. Here's my vertex. I'm going to make a sketch. Looks like this. So the domain is all real numbers. Duh, it's a parabola. The range, well, it bottoms out right there. What's my lowest y value in this problem? What's my lowest y value? How low does it go? Good. Melody says negative 3. She's right. The lowest point, negative 1, negative 2, it goes down to negative 3. So the range would be greater than or equal to negative 3. All y values is negative 3 and above. Okay, I'll give you another one. Y equals negative x squared plus 5. If you can find the vertex, we're in pretty good shape. Anybody guess on the vertex? Again, it's not something you should know yet, but it's possible because we've talked about it. Well, there's nothing in parentheses here, so it does not go left or right, but the plus 5 moves it up 5. So if I was going to graph this, it would be right here. So Melody, you're right. If she's saying 0, negative 5, this is the sketch of it. It opens down and it goes up 5. So the vertex is 0, negative 5. There's my vertex. Okay? So now, what would the range be? What y values are possible? Does that have a high point or a low point on this parabola? Like, is the vertex the highest point or is it the lowest point here? What do you think? What do you think, George? It's highest. Good. Like it go up, it reaches its peak, and then comes back down. Good, Melody. Okay, this one has the lowest point. So we know that it's going to be greater than or equal to negative 3. Here, we know all of the points, or all of the graph is going to be less than or equal to 5. So it's, oh, did I put 0, negative 5? I'm sorry, it's 0, 5. 0, positive 5. So it's got to be less than or equal to 5 right there. That's the highest point. Okay, so your vertex is going to tell you either your highest point or your lowest point on the parabola. And that's how you're going to determine if it's going to, where to start your range, and then it's either going to be greater than or equal to or less than or equal to. All right, so that's domain and range for these. If you wanted an absolute value, it's done the same way. If it's x plus 1 minus 4, we find the vertex. And the vertex of this one is. I keep doing plus inside. Emma, any thoughts on the vertex for this one? So the plus 1, do you know what that's going to do to it? We're still learning it. There's a lot of information. Haley, do you know?
Would the vertex be negative 1, negative 4?
Wait, now I'm in the wrong mode, so I can't see who is talking. All right, who was that? Was that you, Melody?
Yeah.
Negative 1, negative 4 is correct. Yeah. So it's the opposite of plus 1, so it'd be negative 1, negative 4. So the vertex is negative 1, negative 4. So if I was going to make a sketch of this, I would go left 1, down 4, 2, 3, 4, and it opens up because there's a positive out front. There's no negative out front. So it just kind of looks like this. So just to finish this off, what would the domain of this function be? The domain. Absolute value, because it goes forever to the left, forever to the right. You can't take the square root of negative, can't divide by 0. So the domain, we would say all real numbers. And then for range, does that have a low point or a high point here? Tori, is the vertex the lowest point or the highest point on this absolute value?
Lowest.
It's the lowest, good. So our answer is going to be, if that's the lowest, our y has to be greater than or equal to whatever that is, which is -4. Because our graph is above it, so it's got to be greater than or equal to -4. All right, so that's domain range. We'll spend more time on this tomorrow. Do what you can with the assignment. I'll have some time probably to answer questions tomorrow in class. Otherwise, we'll revisit this and make sure we understand what's going on. Questions?